अगले जनरेशन को
मैं अंदर था। नहीं आप फिजिक्स से नहीं। मेरे केमिस्ट्री में काटा मैम ने। मैंने पीटी के एनो 3 लेता था, फिर मैंने काट दिया। हिंदी में क्या है?
New admission? Okay, so pen open. ऊपर का उल्टा उल्टा पीछे और वो ऊपर बाजू में। Where did we stop in the last class? Where did we stop? Rest myopia completed? Okay. So I mentioned I have written the artifacts on the board. You have to tell me what it means, and then you have to tell the correction. How we can rectify it.
Sir, today only my test.
For this?
Whole chapter.
हाँ यहाँ पे हो गया ना टेस्ट. UT टेस्ट. अच्छा स्कूल टेस्ट. कैसा गया? ठीक हो गया?
फिजिक्स का टॉपिक है.
मैं वही तो बोल रहा हूँ. ठीक से सुनेगा तो एक भी नहीं कट होगा.
फिजिक्स में
विश्वास नहीं हो रहा था. कितने में से 10 है? 13. तो ठीक है ना. अगर पूरा सुनते तो 13 आ जाता. ठीक है. क्या बोल रहा था? मायोपिया नियर साइटेडनेस. तो डिफेक्ट क्या हुआ? दूर का चीज नहीं दिखता. करेक्शन डाइवर्जेंट वही दोनों एक ही. ठीक है. चलो आई विल चूज हु विल आंसर. मालूम है एक ही मार्क्स. चलो तुमने अटेंड किया आई डिफेक्ट्स. हाइपरमेट्रोपिया. व्हाट इज द डिफेक्ट? Tell me in terms of which point is defective, near point or far point? Which point is defective? Near point is defective. How to correct it? Convex lens. So what happens in the defect? Where the image is formed? When the hypermetropic eye tries to see a near object? Behind the retina. है ना? क्या होता है? The eyeball is flattened. Behind the retina. और उसको खींच के रेटिना पे लाना. मतलब क्या करना है? कन्वर्स करना है ना. इसलिए कॉन्वेक्स. हाँ फोकल लाइन ज्यादा है तो उसको अपने को ज्यादा बेंड करना है. तो कन्वर्टिंग लेना है. ठीक है. ये सब लॉजिक याद रखो. वैसे ही मायोपिया में क्या होता है? इमेज कहाँ पे बनती है? फार ऑब्जेक्ट देखा तो इमेज कहाँ बनती है? रेटिना के सामने. उसको पुश बैक करना है. तो डाइवर्स करना. ठीक है. ऐसे एक आंख में दोनों डिफेक्ट हो सकते हैं. बोथ मायोपिया एंड हाइपरमेट्रोपिया. That is not transparent. That I have not written. There is a combination of both myopia, hypermetropia. Together भी होता है ना?
हाँ सर.
ये जो together होता है.
वहाँ पे इमेज कहाँ बनता है?
हाँ?
उसमें इमेज कहाँ बनता है?
या तो आप नजदीक देखेगा तो पीछे बनेगा, दूर देखेगा तो आगे बनेगा. दोनों जगह बनता है. मतलब उसको दूर का भी नहीं दिखता है ठीक से और पास का भी नहीं दिखता है. तो उसके लिए क्या लेंस यूज करेगा?
बायफोकल।
बाइफोकल, ठीक है ना? तो इसके लिए बाइफोकल लगा, मतलब इट विल बी कॉम्बिनेशन ऑफ कॉनकेव एंड कॉन्वेक्स। कॉनकेव इन द अपर पार्ट, कॉन्वेक्स इन द लोअर, ठीक है? प्रेस बायोपिया क्या होता है? रुको आई विल चूज। यस, प्रेस बायोपिया कौन जानता है? हाथ ऊपर करो, बताओ।
Presbyopia is basically hypermetropia of old age.
Very good. So you picked that up. Huh? So it is nothing but hypermetropia only, but the ciliary muscles. Now listen. Ciliary muscles become weak in the old age. Then what happens? If ciliary muscles become weak, then what happens?
It won't be eye contact with the lens very well.
The lens है, वो भी old age में it loses its flexibility. So difficult for ciliary muscle एक तो weak हो गई, lens को compress ही नहीं कर पाता, lens thick नहीं हो पाता, उसका converging ability reduce है, ठीक है? हाँ, मतलब focal length change ही नहीं कर पाता, ciliary muscle weak हो गया, कुछ कर ही नहीं पाता, तो इसलिए क्या करना पड़ेगा? Which lens? Converging, ठीक है? Now that is presbyopia. Cataract, did I explain?
Yes.
Yes, we have just done the topic. Like,
So what is cataract? Anyone? Yes.
So is when the eyelens becomes big or opaque, it is only corrected by the surgical
Yes.
method.
Yes. So once the eyelens becomes milky or opaque, now the light is not entering only. So forget about seeing anything. Okay? So the lens has to be replaced with artificial lens. So the old lens is broken, removed and replaced with silicone lens. Okay? So now it has become a very standard procedure for about 2.5 hours, and then the person can be discharged on the same day. Okay? An alternate eye, it has to be done.
Does it feel different to have a silicone lens?
Huh?
Does it feel different in an eye to have a silicone
Can you
lens?
feel your lens right now?
Wow, what an answer. So it is a accepted practice, so possibly not, because I can't tell you, I am yet to experience it. Nahin,
But you might feel it if you change the
only till your body has become accustomed. The initial irritation, once the body has accepted the foreign body, then it's fine. Okay. All right. So we have covered all the eye diseases. Let's move on. Next part is this dispersion of light, right? What is next one?
Prism.
Wait, dispersion of light. Okay. So dispersion of white light by glass prism, or before that you have refraction of light through a prism. Okay. This also had started.
No.
So what is a prism?
Prism is a triangle, 3D triangle.
It's a
With-
pyramid.
Prism is a prism.
Sir, ये started
हाँ,
ये started
ठीक है. तो कोई बुराई है क्या? कहीं तो है.
doubt था.
ये कोई डाउट नहीं. So what is a prism? Prism is a transparent medium with 3 rectangular surfaces and 2 triangular. It has 5 surfaces. ठीक है? So the prism is looks like this. Okay? So this is what is prism. So you can call the 2 triangular surfaces as ABC, DEF. So how many rectangular surfaces?
So 3 rectangles.
ADEB, ADFC. So these 2 surfaces are called refracting surface, right? So from this side the light enters and from this side it will come out. Okay? Yeah, that's the base. EFCB, that is base. So this is the base of the prism. Base of prism. What are these surfaces? These two surfaces are refracting surfaces. Okay. There's all. Now I have two triangular surfaces, ABC and DEF. Triangular surface. Okay, so prism has in total how many surfaces? Total 5.
surfaces.
Okay. Now, so this is called the angle of the prism. Angle of prism. When a ray diagram is drawn, we only make the triangular face, ABC. Let me make it little big, so that all the angles are easily readable. Okay, so in the ray diagram, we only make the triangular surface. So like I said, the light will enter from this side, ADEB side, and it will come out from ADFC. So how do we draw the ray diagram? You first mark the midpoint of
We
AB.
take 90 degrees.
Okay, mark the midpoint of AB and also mark the midpoint of AC. Draw two normals there. Right? So this I just have drawn for your knowledge. Basically, this is what you have to remember. The ray diagram for refraction of light through a prism. Now, how to draw the incident ray? Start from the baseline of the prism, okay? See the technique, how to draw the correct diagram. Start the ray from the baseline of the prism, somewhere here. And this point, the intersection of normal and face AB. Join these two. This is the incident ray. You have to start from the baseline. What kind of ray is this? Is it white light or?
White light.
Not initially. That's when we discuss dispersion. Right now it is monochromatic ray. Mono means one, chromatic means color, single color.
Oh, means it can be a
Yellow, red, any one color. Monochromatic incident ray. Because right now we are not discussing dispersion, we are discussing refraction. So refraction involves only bending. So what is the original direction? This is the original direction. Now is the medium changing?
Yes.
The light is entering from air to glass. So its path will bend towards normal. Who is chatting constantly? Again. So it is bending towards normal. So let me name this normal as N1, N1 dash. And this normal is N2, N2 dash. N2, N2 dash. So inside the prism, the ray has bent, the refracting ray has bent towards normal. What about this? What at this point? It should bend towards normal or away?
Away from
Away, because now it is entering from denser to rarer. So again you bring it towards the base of the prism. Let's name it P, Q, R, S. Right? So let's mark the angles. So this is angle of incidence. Then this is angle of refraction. So these two angles. And this is angle of emergence. What is ABC? ABC is principal section of the prism. Then PQ is incident ray. QR is reflected ray. RS is emergent ray. N1 dash and N2 dash are normals. On base AB. And AC. Now mark all the angles. So we have angle I is incident, angle of incidence. Then we have angle R, angle of refraction. Angle of emergence. Angle A. Angle of prism. There is one last angle called angle of deviation. How do you get angle of deviation? You have to extend the emergent ray backwards and join with the original direction of incident ray. So this angle is called angle of deviation. So we mark this point as G and H. So delta is angle of deviation. Delta, small delta. So sometimes the question comes just to draw this diagram and get all the marks. Okay? Draw the diagram showing refraction of light through a prism. So you have to draw this.
How many arms?
Depends on these two generous, maybe 2 or 3. 3 का मार्क्स है. तो उसका टेक्निक मैंने बताया कैसे स्टार्ट करना है. ट्रायंगल बना दिया, बेस लाइन से रेस स्टार्ट करो AB के मिड पॉइंट पे, फिर अंदर bends, it becomes parallel to the base. Then when it comes out again, it goes to it's a symmetric direction.
Sir, what is the angle?
Angle is angle of prism. This one. The angle between two refracting surfaces. Okay, angle between two refracting surfaces is called angle of prism. Now we'll study about dispersion of light. Let me know once you're done writing. Done writing? Beta? ये equilateral सुना दिया The prism should be equilateral.
So how exactly I'm supposed to make the sign for diagram? It's like an S with a loop.
S with the bottom completely touching the transverse. Or an unfinished 8. Okay, let us discuss. Can we discuss now? Now in this diagram, this monochromatic ray will now be replaced by white light. Okay? Now once the white light enters, what is seen here is the white light is split into 7 colors. Red on top and violet at the bottom. So it's entirely with gear. Bottom up is with gear. So how do you explain this? So when you have white light, now you have a white light here. What we get is this kind of a thing. When we place a screen here, so you get red color on top, violet at bottom, and here to here, you get every color: V, I, V, G, Y. So the entire band of colors is formed, and this is called spectrum of white light. Spectrum of white light. So why this happens? So you can join all the colors here. Okay, likewise you will have 7 rays here. ठीक है? Can anybody explain the reason for splitting of light? What is the reason for splitting of light inside the prism? Scattering is different. Scattering is a different phenomenon.
Because it disperses and forms.
Why it disperses is the question. Splitting of light is called dispersion.
Difference of medium.
Difference?
Of medium, the medium change.
No, sir, because of the wavelength.
Yes. Who said that?
Me.
Yeah. So because of the wavelength, meaning what? What is wavelength? What does wavelength of the light signify?
The number of colors.
Yes. Wavelength signifies. It doesn't believe. Wavelength of the light signifies the color of the light. Okay. Now red color. What is the wavelength of red color? What is the wavelength of red color? Roughly 8,000 angstrom. And this is roughly 4,000 angstrom. What is the wavelength of? What A? This is lambda. This is lambda.
Sir, can I say this?
Okay, bad. Whatever the. The back is So wavelength signifies the color of the light. Okay. So why the splitting of light takes place? Can somebody apply the brain and tell? Figure out. So the bending is different for different colors. So what does this mean? It means the speed of different color is different. Red has the highest speed, violet has the lowest. Yes, this is the reason.
That's why they use red color in this.
So all colors of light travel with the same speed in vacuum. Okay? All these colors travel with the same speed in vacuum. What is the speed in vacuum? 3 into 10 raised to 3 into 10 raised to 8 meter per second. This is the speed with which all the colors travel in air or vacuum. But in any other medium than air or vacuum, the speed of different colors of light is different. Okay? So splitting of light, splitting of white light into its component colors in prism is called dispersion of light. What is dispersion of light? Splitting of white light into its component colors in prism is called dispersion of light. So reason for dispersion. Whereas Okay, so the one which travels with fastest speed bends least, and with the slowest one bends maximum, and everybody else proportionally. So this is all you have to understand about dispersion of light. One of the application of dispersion of light is rainbow formation.
Sorry.
Yes,
Uh,
the application of dispersion of light is rainbow formation. Anybody who's seen rainbow in real life?
yes.
Quite a few. Where did you see it?
Sky.
So what are the conditions for rainbow formation?
Sun and body are same.
Sun and rain. So sun and rain simultaneously in the same area?
Yes.
In the same area?
No.
You should be able to see sunlight as well as rain. Will the sunlight be visible when it is cloudy?
No.
Okay.
The light
Still up there.
Cloud is here.
is a ray that must
So sun should be behind observer, right? Sun is here. And rain should be falling in front of the observer. Okay? This is what it is. So let us say this is the water drop in the sky. You can see that. Even if you see this tubelight with your scale, okay, you will see rainbow. Means you will see 7 colors. Basically, let's understand the rainbow formation. Yeah, okay, right first.
Excuse me.
Everybody is blue. Which blue you want? Which boy in blue? Done with this one. Shall we discuss rainbow formation?
No, sir. So,
अरे जल्दी करो ये सब use freehand
sir, मैंने बताया था कि इसका वजह से
So arrow without arrow. Everywhere there should be arrow labeling which color is red, which is violet. So conditions. Let me write first the conditions. Yes.
What's the reason why red is on top and violet is on
Okay, so
Yeah.
वो लिखा होना देख
क्या है ये सब?
आजकल के टॉपर भी
No loose commentary. अभी तो बताया. ठीक है. So what are the conditions for rainbow formation? Sun behind observer, rain in front. New book में भी है. Rain in front of. So rain behind observer, sun behind observer and rain in front of him. It is total internal reflection. Total internal reflection. It is an advanced topic to be covered and studied in 12th standard. लेकिन ये तुमको TIR दिया है, अभी तुम लिख लो इसको ऐसे. मैं explain करता हूँ where TIR is taking place. ये conditions है: sun behind the observer, rain in front of the observer. Total internal reflection, ठीक है? And end में refraction. तो देखो क्या होता है? When the sunlight enters, this is some water molecule suspended in space. Okay, water molecule suspended in space. Now this is a white light, right? White light entering the water molecule. Now water molecule, is it denser or rarer as compared to air? Denser. So you will have this kind of thing taking place. Okay, so dispersion will take place. So what will happen? The splitting of white light into its component colors. And this is where, so this is point number 1. Point 1 पे क्या हो रहा है? Refraction and dispersion. यहाँ पे क्या हो रहा है? PIR. मतलब मैं लिख देता हूँ यहाँ पे. This is dispersion. यहाँ पे ये तुम्हारा वाटर ड्रॉप. यहाँ पे हो रहा है TIR. What is going on? Okay, girls. Now, boys are well behaved now. You want me to treat you all the same, the way I treated boys? So, better behave well and be silent.
Sir, dispersion takes place from denser to rarer.
Rarer to denser. What is prism? Denser medium. So whenever white light is entering the denser medium, that's where dispersion is taking place. So here from air to water, water is a denser medium. So the splitting is taking place, just like this.
So denser to
Where is the splitting taking place? Dekho, dispersion is taking place here. Here is dispersion at this space, AB. What is happening here? Only refraction. Is the splitting taking further? No, it's only spreading, not splitting. The red is bending further. but it's not becoming like 7 into 7 49 colors. ऐसा नहीं हो रहा. So only dispersion is taking place at this space, not here. Here is only refraction. So in this case, third place, refraction is taking place here. Refraction only. This question is asked. What is taking place at two faces of the prism? First phase, refraction and dispersion. Refraction is leading to dispersion. No? What is refraction? Bending of light in the direction. So because bending is different for different colors, so that is leading to dispersion. Refraction is causing dispersion at the first phase, and at the second phase only refraction. Now it's only bending, no more splitting of colors. What is bothering? Spread हो रहा है, further bend हो रहा है.
See, when light travels from the glass slab to the air, it turns.
Here the spreading of the splitting happened here. Look here, splitting of white light till here, till this point. Now it is not white light. Now these are individual colors. These individual colors only are suffering refraction now. Are the colors adding up? This is red and violet only, no? Here
So in
also.
the second case,
It's only refraction.
in the rainbow over there,
Yeah.
the light from the sun
Entering here at this
is
point.
entering on there.
So dispersion here.
Yes.
All the colors are split. Now this is total internal reflection. Reflection, total internal reflection. Okay? Then it is coming out. At it again. मार दूंगा कान के नीचे. ये रिफ्लेक्शन है.
Reflection हो रहा है.
रिफ्लेक्शन
बस
ये इंटरनल. लिसन वो इंटरनल रिफ्लेक्शन हो रहा है जिसका थियरी तुमको 12th में पढ़ाया गया अभी नहीं. ओके, सो यू जस्ट रिमेंबर. नहीं तो रिटर्न कैसे होगा बगैर रिफ्लेक्शन के? नहीं तो रिफ्रैक्ट होता तो बाहर निकल जाता. फिर यहाँ पे रिफ्रैक्शन हो रहा है. फाइनली इट इज रिफ्रैक्टेड. अंडरस्टूड?
I don't understand.
देखो प्रिज्म में यहाँ से बाहर आ गया था ना, अब ये बाहर नहीं आ रहा है, अंदर रिफ्लेक्ट हो रहा है.
Why is it not visible?
वो थ्योरी तुमको 12th में है. ओके, दैट थ्योरी इज इन 12th. वी आर नॉट डिस्कसिंग व्हाट इज टोटल इंटरनल रिफ्लेक्शन. एक्चुअली तो वो टोटल इंटरनल रिफ्लेक्शन हो भी नहीं रहा है, वो गलत दिया तुम्हारे को. ठीक है, बट एनीवे वी विल नॉट डिस्कस फर्दर ऑन दिस. ये हो गया तुम्हारा रेनबो. जस्ट देखो कैसे इसको ड्रॉ करना है. दीज आर द कंडीशंस. ठीक है. नाउ व्हाट रिमेंस इज एटमॉस्फेरिक रिफ्रैक्शन एंड स्कैटरिंग ऑफ लाइट. ये दो टॉपिक है. एंड स्कैटरिंग ऑफ लाइट, ये दो नो scattering of light. ठीक है, क्लास खत्म होने के बाद जाओ, जब घर जाना है पढ़ाई छोड़ के वॉशरूम जाओ. एवरी टाइम यू आर आस्किंग लास्ट 5 मिनट. This chapter has minimum numericals but maximum concept. ठीक है. Now what is atmospheric refraction? एग्जाम दिया ना आज.
particles
देखो अभी we will understand it with the help of. So let us understand atmospheric. This causes twinkling of stars.
Sir, because it is far from not close as compared to the sun.
बोल रहे हो. So this is I am explaining atmospheric refraction. Earth is enveloped by atmosphere. Okay? So this is Earth's atmosphere. The twinkling of stars. We are discussing twinkling of stars. देखो अगर ये स्टार यहाँ पे है ठीक है when the light from star enters Earth's atmosphere अब यहाँ पे क्या होगा let's say the observer is here so this light this is space till here it is space now atmosphere is a denser medium as compared to space so it will now bend it won't go straight it will start bending now so it will bend yes. In the atmosphere it is bending right after entering the atmosphere right after entering the atmosphere it is bending like this okay so if you have an observer here you will see the star position somewhere here what will the observer see the apparent position of the star this is the actual position of the star but observer will see the position of the star here why this light ray is bending देखो as you travel from upper layer of the atmosphere to lower layer the density of the layer is increasing density of the layer close to earth is more so it is atmosphere doesn't have uniform density atmospheric layers don't have uniform density density is less at the upper layer so the bending is less as the light enters closer to the surface of earth so it becomes curved because it is continuously bent not like prism that here it bend once and then the straight line it's not like this it is a curve it curved like this so the apparent position of the star shifts for the observer he feels star is here what the observer feels star is here now this is a dynamic medium it is not a fixed medium like prism so the density one is it changes from top to bottom layers plus that density does not remain fixed air is flowing all the time right so that density also changes so this apparent position keeps shifting up or down okay but when somebody is watching star his vision is gazed in one direction so if he is seeing the apparent position of the star sometimes the star is visible sometimes it is not because the apparent position also is shifting atmosphere being dynamic medium atmosphere being dynamic medium the apparent position keeps shifting that gives the sensation of twinkling of star because he is fixed his vision in this direction suddenly it goes up and down due to dynamic nature of the atmosphere is it understood now so that gives the sensation of twinkling of star
So the apparent position changes. It doesn't
yes what is visible to the observer is apparent position only but that also keeps shifting
because it's a dynamic.
yes so atmospheric refraction so this whole thing is called atmospheric refraction the dynamic shifting and all that okay so this is atmosphere is a its medium
So then why does the same happen for the sun?
dynamic
Sun
medium
is not that far below.
It's still pretty far. As long as it is out of the orbit, the shifting will happen, right?
Makes sense.
So atmosphere is a dynamic medium and layers with increasing densities. So I just explained what happens because of that. Because the layers are increasing density, the bending is curved. नहीं समझ आया तेरे को इसको पूछ रहा क्या बता रहा है कहाँ पे? Atmosphere is a dynamic medium and it has layers with increasing densities. मतलब upper layer से नीचे की layer में जाओगे तो density constantly increase होगी. And as लिख दो यहाँ पे. And as layers with increasing. ठीक है? तो twinkling effect समझ में आ गया कैसे हो रहा है? Okay. So this completes our discussion on atmospheric diffraction and twinkling of stars. Then why bigger planets do not twinkle? Moon क्यों नहीं twinkle करता?
Sir, because of the distance between the observer and
So?
the object.
So
Sir, if
moon is much closer as compared to star. So उससे क्या होता है?
Sir, so the light will scatter less.
Now look here. If moon is here, let us say moon is here, right? So the twinkling is within the periphery of the moon, correct? So basically क्या होता है? Let us say ये वाला spot अगर ऊपर गया, apparent shift हुआ तो नीचे वाला spot भी तो ऊपर आ जाएगा. So it cancels the apparent shift of various. So various point can be treated as point sources of light. The planet or the moon or any object which is closer, right? Various points on the planet can be treated as point source. Star itself is a point source. So here you have multiple point sources. So if one source shifts, the other source shifting takes its place. So the twinkling effect is cancelled. Okay? So that's the reason.
So it is technically twinkling, we just don't notice.
You don't notice it because for that there has to be difference. Appearance, disappearance. So disappearance of one spot is replaced by other spot. Okay, so that's the reason that twinkling is not visible in this case. The other application of atmospheric refraction is.
So what about the sun? The sun is very far away.
No, even sun. Sun is not as far away as the star.
But
Sun
still
is
very far away.
still, but it is also very big. It's very far away, but not as far as stars. Right? Next thing is early sunrise and delayed sunset. So what is this? What does this mean? When you see the rising sun, it is actually not risen, but you feel that it is already risen. There is a 2 minutes delay, right? So how do we explain this? Dekho. So let us say this is Earth's horizon. This is Earth's horizon. And let us say this is the atmosphere. Now, if you have sun below the horizon, meaning sun has still not risen, it is below the horizon. But if the observer is standing here, when the sun ray enters the atmosphere, okay, so it gets curved like this in the atmosphere. Okay, so what does he feel? He feels that the light is coming from here. Although sun is below the horizon, but due to atmospheric refraction, the apparent position of the sun is above horizon. ठीक है, तो ये हो गया. And at the time of sunset, the sunset has already taken place, but it still continues to see the sun. So now it is opposite, delayed sunset. So early sunrise and delayed sunset takes place due to atmospheric refraction.
So oftentimes, even after the sun sets, there's still a lot of light.
Yeah, that is due to scattering. That's a different thing. That is the next one. And we'll cover that in the next class.
It's called twilight.
Huh?
It's called twilight.
Maybe just a English interpretation. What is twilight? Two lights?
No, twilight is the light after the sun sets.
Ah, so that's just a term, right? So what is remaining is only Tyndall effect.
Yes. त्याच्यात तुम्ही 10% कापले तो वाला
कधी लवकर
लास्ट वीक लास्ट मंडेला दिला
मंडे ना आज मंडे आला